Hi viewers, in this session I am going to deal with a basic simple problem on Coulombs law. Let us take the problem. Point charges 1 millicoulomb and minus 2 millicoulomb are located at 3, 2, minus 1 and minus 1, minus 1, 4 respectively. Calculate the electric force on 10 nanocoulomb located at 0, 3, 1. Now here we are going to use the force on 2 point charges due to another charge, that is q by 4 pi epsilon naught summation I equal to 1 to n q I into r bar minus ri bar by r bar minus ri whole power 3 by 2. Here the total number of charges are 2, and if you see the locations of each charge, the first charge is indicated by 1 millicoulomb and second charge is minus 2 millicoulomb. The position for first charge is 3, 2, minus 1. So we can identify the point 3, 2, minus 1. Along x direction 3 units we have to measure, and along y direction 2 units. So resultant of 3 and 2 is nothing but 3, 2, and this point corresponding to 3, 2, 0. And from this point you have to measure minus 1 units along z direction. So this is where the positive direction of z, and we have to move downwards with a distance of minus 1 units. So now this point corresponding to 3, 2, minus 1. Here the charge q1 is placed. Right. Now the second charge q2 minus 2 millicoulombs is placed at minus 1, minus 1, 4. So along negative x direction minus 1 units, along negative y direction minus 1, and resultant of these two will be here minus 1, minus 1, and from this point you have to measure z distance of along z direction. So this point corresponding to minus 1, minus 1, 4. So the distance between q1 and q2 is nothing but the difference of r1 bar and r2 bar. So here if you see the position of the second charge, that is minus 1, minus 1, 4 with respect to origin 0, 0, 0. So we will get the distance vector, the Cartesian coordinate system, minus ax cap minus ay cap plus 4az cap. And for the position of charge q1 with respect to origin, r1 bar is nothing but 3, 2, minus 1 minus 0, 0, 0. In the vector notation we can write 3 into ax cap plus 2 ay cap minus az cap. The distance from the test charge q to q1 is given by 3ay cap plus az cap minus 3ax cap plus 2ay cap minus az cap, where the test charge q is placed at 0, 3, 1. So the magnitude of the distance we can find out by taking square root of x coordinate square plus y coordinate square plus z coordinate square. That will becomes of root 14. So similarly, the distance from the test charge to the charge q2 is given by ax cap plus 4ay cap minus 3az cap, and magnitude of this charge will be root 26. Now the force acting on Q with respect to Q1 and Q2 is given by Ft is equal to F1 bar plus F2 bar. F1 bar is nothing but it is the force between the charge Q and Q1, and whereas F2 bar is the force between Q and Q2 bar. So the total net force can be calculated by using this formula, and finally 1 by 4 pi epsilon naught value is taken as 9 into 10 power 9. The charges Q is 10 into 10 power minus 9. Then we get this after simplification we are going to get 6.527 Ax cap minus 3.817 Ay cap plus 7.506 Az cap millinewtons. Thank you, one and all.